This is going to be a discussion in a couple of areas. One is we're going to talk about media processing, audio and video processing, but more interestingly, we're going to talk about how service providers can use the concept of keywords and voice-activated automation, voice-activated detection of keywords as part of a stream, an audio or a video stream, and how they can use that as to create new revenue streams, to create new kinds of capabilities. So that's why the Hey Siri. So Siri is, obviously, for maybe most people know, is the voice-activated assistant as part of Apple. I could have put Alexa, hello Alexa, but really this is going to talk about for a telecom audio stream, how do you embed voice recognition seamlessly as part of that flow? So let me jump in. We'll talk first about Media Engine and the Media Server product. Then we'll go into a little bit of why this is important, why this area of keyword detection and how that's affecting the industry, how that whole area plays out. We'll talk about it, and finally we'll finish with the deployment options. So we see three major trends for media processing and IP networks: expanded domain of contextual IP communications. That's video collaboration, voice and video, or LTE, Wi-Fi. I mean, we see a lot of that, and that's expanding. There is a tremendous amount of user-generated content. User-generated content, whether it comes from video feeds, audio feeds, whatever is submitted by users, that is expanding. And we also see the rising open architecture in the cloud economy, more focus on open architectures. That's why we'll talk about disaggregation and open architectures, because this is hard to do if you don't have an open architecture that can support these kinds of capabilities. Closed architectures find it hard, but this one, we believe, is the winning way for these types of applications. For these trends, what do we see as the result? We want to see cost-efficient multi-service enablement. We want to optimize media quality experience and cost at the edge, and we want our service providers want to ensure high performance in a cloud environment. These are all kind of the basics just to set the stage. A quick view of our media engine itself. There are multiple layers here. Media engine is software that we sell. We sell in software, there's hardware forms, but ultimately it is platform agnostic software. Can run bare metal, DSPs, GPUs, private clouds, public clouds. There's a core functionality with play record, DMTFs, ASR, conferencing, and so forth. And on top, there are software packages that can do HD video, audio, transcoding. And finally, you can have a range of real-time communications, everything from WebRTC, unified communications, transcoding, along with content optimization. And we'll talk a little bit about the edge, why this is important at the edge. But fundamentally, the media engine enables differentiated real-time communication. And that is key for a lot of service providers going forward, that differentiation. How do they differentiate? And that is the key to bringing in new revenues. Simplifies multi-technology, multi-vendor interworking. If you have a common MRF, if you have a common media server that can work with different application servers, then you can start to coalesce. You can have a common interworking among them. And how can you do this cost effectively? How can you move this to the cloud and an open architecture? A little bit about the service delivery platform that we offer, the Media Engine platform. We can do everything from support for VoLTE, IMS, traditional multimedia messaging. We'll talk about the speech-enabled applications, audio-video collaboration, analytics, value-added services, WebRTC. All of this is supported by our Media Engine. And because it is open, because a lot of it is open source and standards-based, lots of CapEx reduction and tremendous TCO. By the way, all this is elastically scalable both in a private cloud as well as a public cloud. So you can run on Amazon, you can run on your private cloud for these types of applications. Where do we fit in the big picture? The red is the media server running as VNFs. We can run on top of DSPs. With DSP acceleration, GPU acceleration, we work closely with Intel. And we will talk about two SDKs, actually Intel SDKs. One is called Intel Media SDK for encoding, decoding, and so forth. And another is OpenVINO, which is an AI library that runs on top of x86. You do not need GPU acceleration. If you have GPU acceleration, great, but you can still run this on x86. Our product has been integrated with multiple VNFMs and EMS. We are fully integrated with ONAP, with the Nokia Cloud Band, ZTE, memory, and so forth. We run on top of OpenStack. You see the complete set here, VMware, EC2, Amazon Web Services. And of course, depending on the number of sessions, depending on how much you need to accelerate this processing, you could do this with accelerator hardware. You could run this with DSPs, you could run this with extra GPUs. All of that is possible with this architecture. So what does media optimization ultimately provide? It can provide integrated, what we believe is integrated speech recognition and in-call keyword detection. What does that mean? As I'm talking to you, as we're talking, it can be, by the way, it can be either a point-to-point stream or a point-to-multipoint or a conferencing stream. You can detect any word based on a library, and we'll talk about it. And today, it is based on US English, but it can be customized for any language. It has built-in acoustic models, so you do not have this, you don't need to train. There is no training needed for all this. And these capabilities you can offer, like I said, multiple languages, but even more importantly, it is agnostic to the age of the speaker. It is agnostic to the gender. It's agnostic to all of those things, and you can embed this functionality into the stream. So that's the in-call keyword detection, reduces costs, and we'll talk about how it improves user experience. You can do high-volume video and voice analytics to improve business processes and so forth if you're a call center. You can take this and put this at the edge. And why would you want this at the edge? One of the key reasons we believe is if you had a large amount of video streams coming in and you wanted to perform some processing at the edge so that you actually did not burden the core, that's an important application that we can perform. And last is on-the-fly media adaptation, transcoding and transcreating of user-generated content that enhances QoE. But we'll focus on a couple of these, the edge and the voice recognition. Let's talk about keyword detection market today. This market is growing incredibly rapidly. We see the explosion of applications tied around Alexa, the Amazon product, around Google Cloud, around every major vendor has this. So part of our question is, how do we get telcos, how do we get service providers in on the action? Because this is a market that is growing incredibly fast, and natural language processing will be the primary method of access to services in the future. Whatever we do today using CLIs, using text-based, this, that, and the other, ultimately is moving towards voice-based. And how do we get telcos in on the action? That's part of what we will talk about. Basically, the solutions are not in line. These are all done over OTT today. And there's a reliance on external digital assistants, whether it's Alexa, Google, and speech servers, so they can be both expensive, and the problem is they are, ultimately, there are privacy issues. So there's issues with cost, performance, flexibility, user experience. All of these are issues in the current solutions today. How do we do this? Our media engine sits in line in the audio or video path, and we can perform audio decoding, keyword detection, and we can, there are quality enhancements we can perform. And once that action is taken by the media engine, the detected keyword, there are signals sent out as DMTF digits to the application server. So this line here is once a detection has happened. But before you do that, you have to enable keyword detection, and you have to specify the keywords. And the keywords you specify, we're not talking about audio files here. We're talking about plain text. You can put in, if you want, you can even put in Hey Siri as the keyword. Or we have done this with a keyword Hey Nadia. So we have done this with Hey Nadia, Hello Nadia, Hi Nadia, is the keyword that the system will detect and allow us to trigger a set of actions based on that trigger. So we can take the audio stream at that point and feed it to an external server. We can perform an announcement. We can perform a range of actions once you detect the keyword as part of the stream. By the way, this can be applied to audio and video, and we'll talk about the video case where you want to perform some form of inline, let's say, analytics and trigger certain actions. But that is the main path is audio decoding, keyword detection, and the quality piece. External is application server and the ASR server. ASR is automatic speech recognition server. It's optional if you want to do something externally also. Key benefits, much lower cost than traditional approaches. The accuracy of speech recognition, we can improve the quality of the speech that comes in from the codecs, and so you can actually increase the accuracy of speech recognition. And we're talking about here 90+%, 90, 95. Those are the ranges we are talking about. And these are for a number of standard, what we think of as US English words, but they can be also applied. These can be applied to other languages also. And the nice part is there is no training required. Cost effectively scales to support in-network recognition, optimizes performance by avoiding latency complexity, all the extra processing, because you're already doing this processing today. Whether you're doing bypassing, whether you're doing transcoding, this processing is being done. And you might want to add this as part of the ability to generate new revenue streams into the stream that is already there. And this enables new services without requiring any software downloads. There's nothing required on your customers' phones. It's all done in the network. 3 use cases that there are a number of use cases, but I've just highlighted here 3. You could have public safety and voice detection, high quality voice biometrics for investigations, SOS messages under network conditions. This can be applied to legal intercept, many kinds of potential actions based on voice detection and keyword detection. You can have this for call center and keyword-based IVR that can anticipate callers' needs and improves customer satisfaction. If the word supervisor is, for example, specified, you might want the supervisor to step in right away. Or you can think of if there are certain actions or certain keywords in there, then we can absolutely detect that. And the list of keywords can be, there are some small limits today, but those can be extended. You can have potentially hundreds of keywords, and the system will be looking for the keywords, all those keywords in all the audio streams at the same time. So if you're in the middle of a conference, if you're conferencing among, let's say, 20 users, we can actually detect the keyword was spoken by whom, and we can take actions on a particular user speaking that keyword, and we'll talk about that. And you can also do targeted marketing and advertising, retailers and marketers to build precise targeted advertising and promotions based on keywords and phrases and conversations. You can actually, obviously there are the legal issues have to be addressed, but ultimately all of these are possible when you are able to detect as part of the voice stream. Examples I've shown here is once we detect, we can report the specific keywords of phrases. You can do accept, reject, mute. For example, if you're doing conferencing, the moderator can say mute, or the moderator can say accept a particular user. You can have sophisticated reporting to the application server, interactive dialogues. You can do this per subscriber, per service type. And by the way, it is speech codec independent. You can do this with narrowband or wideband real-time audio. High accuracy of detection, we are talking really about 90+%, and even higher is what we are working towards. This can be enabled on a port basis, mixers, lots of capabilities can come from this. What does this all provide? Better performance, lower TCO, much lower cost than traditional speech recognition. Traditional speech recognition is extremely expensive, and it is not flexible. It is very hard to deploy on every session basis. Performance is optimized. You eliminate the creation and management of another network element to do all this, because that's how it is done today. This is all seamlessly inline. A lot of our media engine products are used by tier 1 CSPs, both in North America and Europe and Asia. For example, Reliance Jio is a customer in India, AT&T is a customer for us in US, and Deutsche Telekom in this continent. But ultimately, we don't need, these folks don't need to deploy another network element. You can do audio grooming, like voice quality enhancements, to improve the accuracy of detection. Transcoding is, of course, part of all this. Value for service providers, stickiness. We talk about differentiation. This is how you get differentiation. This is how you can differentiate. So we can even do things like, you can say, hey, Nadia, as part of the audio stream, and you can take the rest of it and you can feed it to Siri. You can basically say, hey, Nadia, and middle of this, if I want to say, in this conversation, I want to find out what is the cost of, let's say, an airline trip back to the United States. You can do that in the middle of the conversation. You can say, hey, Nadia, Siri, tell me what is the cheapest ticket from here to New York on Saturday. That is, you might not want to, I mean, it is really contextual, but what it allows you is to provide those kinds of capabilities as a service provider. Let me keep going. So that was, lots of it was based on audio, and this is all based on video. I mean, the same thing could be done for the audio stream also. If you have edge camera and video feeds coming in, and you can perform analytics on those streams that come in, and you can send out notifications or triggers. And this is, you are running now AI on those streams at the edge. Where does this help? If you want to, for security applications, for crowd counting, if you want to only send streams out if the crowd limits are hitting a certain level, certain threshold, then you can absolutely do this with our system. It helps increase revenue, new service opportunities, AR overlay, event-based triggers of audio and video feeds, whatever the trigger might be. The trigger might be somebody saying goal in a match, that can be the trigger, or it can be a video feed saying that, or a video feed where crowd counts go beyond a certain level, or somebody has been recognized. All of that are possible with that. So it's increased revenue, lots of verticals, smart cities, retail, healthcare, industrial IoT, and reduce cost. You can go ahead and drop a lot of the traffic or save it locally for legal reasons that cannot leave a particular location, and you only send the triggers out towards the core network. What tremendous set of opportunities. You can do facial recognition on trained images, detect camera tampering, people counting detection and counting, vehicle detection and counting. What we provide is a platform that enables you to do these things. So ultimately, our customers have control over what is being done. But what we provide is a platform to enable the streams, the audio and the video streams, to be processed the way they would like, and the right kind of value extracted from those streams. This is RAN-aware real-time. So in this case, you can actually have RAN awareness today. The MRF runs way in the core of the network, and the RAN awareness can be brought in as part of this. So you could actually transcode on the fly based on what your RAN conditions are. So if you're at a stadium, and you have multiple feeds coming in, depending on the RAN conditions, you might transrate and transcode the video differently. And that's possible with this system. Lots of highly scalable audio and video applications. I won't go into every one of these, but this is ultimately what we think of as optimizes the cost of ownership, and it allows inline processing. Deployment can be flexibly deployed. It can be in pure hardware form, bare metal servers, VNF acceleration, virtual machines, private and public cloud. All of these capabilities are possible. This can be integrated in a single media server instance, or it can be distributed. You can have a single control location with multiple data locations, either integrated or distributed, depending on my customer's needs. We are the industry leader in this area, in the area of media processing and MRF. About 70% market share. We have 8 million ports deployed, lots of VoLTE and range of trials, and large media-focused R&D. Analytics-driven current optimization, the scalable voice and video service, that's what we're talking about, and multi-vendor, multi-application. By the way, this works with a range of application servers. As long as they can talk MSML or VXML, this will all work seamlessly. And this technology, we believe, is the way of the future. And Radisys, we are absolutely working to make sure we add value. We allow our service providers to create new revenue streams with the lowest possible TCO. Thanks for listening to my talk, and happy to answer questions or.
Yeah, I think we have a moment for a question or two, because our next speaker is just getting mic'd up. If anyone has any question. If not, I actually have a comment.
Sure.
We just finished a project where we interviewed 14 thought leaders working on Edge, and it's very timely that you're talking about natural language interfaces, because one of the key enablers or key enhancers as we roll out compute to the edge is going to be enabling apps that can use natural languages. And I can actually remember back to some of my early days working for a company called Nortel Networks, and I actually worked in their speech recognition lab. And I was a researcher working on deploying voice-activated dialing at the time. And we were actually had to make modifications to the switches, DMS 100s at the time, and we put compute connected to the DMS 100s, but it was very expensive with the architectures we had, and we only ever got past limited deployments and some trials. So now it looks like 30 years later, the technology is getting us to a point where we can actually put the right amount of compute for the right price at the edge of a network.
Absolutely. You can. This is seamless inline processing, and so this processing is anyway done today, and you might as well extract the value, and that's where we see the revenue streams coming in.
So I'm looking forward to seeing some of the things I worked on 30 years ago actually happen now.
Technology marches. Thank you.
And for our next